So let me start first about who am I. I'm Charles Farah. I'm technical director at SIGMAXIM. So I've been at SIGMAXIM for 22 years. So as old as the chairs, actually older than the chairs. Prior to that, I was product manager at PTC for many years, in charge of manufacturing product and pretty much a bunch of products that the products that nobody wants. And before it, I was also at a partner with PTC, mostly on the manufacturing side. So I've been in this world of the Creo Pro Engineer before it, since Pro Engineer release 5. So that's a long time doing things like that. So in the last 22 years, I've been basically specializing in Creo automation. So we look deeper into it at SIGMAXIM. And SIGMAXIM is a company that started in 2001. So we're headquartered in Boston. That's where I am. We have operation in Asia and Europe with pretty much a global customer base. We're a PTC software partner, we're a PTC service partner. And what we are known for really is this automation for Creo. We have over 1 million applications running on Creo with all kind of different versions of Creo. So the scale is right there, and we have to have that scale in order to make sure everything kind of continues to work with the same release of Creo. So what's our mission is basically automation of Creo and the whole ecosystem around Creo. What comes in and out of Creo while you're using Creo. So the idea is that a bunch of steps have to happen usually for everything that you are doing in Creo. You're not just making a feature just because you like to see that feature there or that assembly there. There are a process with multiple steps that has to happen, and automation is to look at it holistically, why you're doing those things, why they have to be related to each other, and basically making a wrap around it that takes this logic and makes sure it executes all at the same time. So our methodology is so we look at it in you can look at Creo and how people use it in a lot of different ways. So and every time we try to kind of like look at the different things that we do as far as automation for Creo. And what we have is certain buckets. So some things we call, on-demand product build. So you think about the idea, the classic idea, what most people think about automating a product is that they would have a configurator, the configurator or selector of options, pick these options usually for the configure to order product, and we want to build the product automatically. So that's kind of a obvious way that how we create automation. The next bucket of practices that we do is dealing with engineer to order products. So how to automate ETO and custom one-off products. And that's kind of a different, although we are dealing with Creo, we are dealing with all this ecosystem around Creo, it's a different way of thinking about how we would automate something like that. The next bucket that I have in here is something we call the virtual master model. And what it is for, once you start looking at products that are very large, very massive as far as complexity or size of these assemblies, you're going to start thinking about how you would automate them. And the classic way that people thought about for years on and how to automate something like a product that is customizable is by using an overloaded assembly. An overloaded assembly comes with its own penalties. It's pretty hard to manage, pretty hard to change, and as the product evolves, pretty hard to keep up with it. So we thought we have a different methodology and different practice in the company that we work with in terms of what we call the virtual master model. That means we don't need an overloaded assembly. We can automate very large product without having to deal with these overloaded assembly that are difficult to manage. We have a new area of practice, which is around MBD. I call it new, but it's something we've been working with for over 10 years. So it's basically tools to support people moving from 2D drawing to 3D model-based definition kind of models, drawingless part. The next part would be something we call best practices and standards. And what it is product that could not be the automation. What people do is not something that you can look at it from top down as a product with a lot of option, but rather it's more custom product that gets built. Think about something like fixtures, like product that are, maybe, custom furniture type stuff. So how do you automate something that is by its own nature is a custom end result? So what you automate is basically the process of building it. So totally different way of looking. It's still inside Creo. It's interactive. Sometimes we call it interactive automation. That's what I like to call it, but it seems like nobody, including our own like marketing and sales, don't like using that terms to catch up, so they're changing it. But this is basically interactively working in Creo to map a process into what it's happening. And the last point is manufacturing. It seems that a lot of those, the drive to automate stuff comes from the design side, production, but really manufacturing is very specific process that is ripe for being automated. So the docs, procedure, route, everything it is in order at the end to create it, including NC programs for people who build them in-house, so machine, that kind of stuff. Okay, so the idea for us is that our scope, because we've been at it for so long, is that if it can be done in Creo, it should be able to be automated. And from there is whether the business supports that process that needs to be automated at the customer side. So that's what we do kind of as a company. And now when we start looking over the lot of these years, we start seeing, okay, an evolving landscape as far as automation with companies that we talk to in order to automate and what it is. So there are three groups of people. So either they are, when we start talking to companies, either they've tried automation in the past and they failed at it. And that's happened so often. It is pretty much people try to automate things and there was no tools. So lots of failures. The problem with those is that they become gun shy. Luckily, these failures has happened at this moment, it's happened way in the past, and we don't see so many traumatized people, but it is something where people has tried it and now they're gun-shy about, like, okay, how would it work for our business? Is the tools there? What would happen, right? The other stuff is that they think their business might be too complicated to be automated, and that also is a lot of companies like that. So they would think that their business can't support it. Automation might be limited. There's how can we use it to improve our process and how we run as a company? And the other stuff is that they really have no assumption, and they're curious about what can happen, and then we have to explore what they do and how it works. So that's kind of the three different areas that we've seen pretty much everywhere. And there are some successes, so I'm not going to say there are no successes. On the contrary, people who've done automation, it's successful. That's great because they've seen what can happen, and now we can go provide them more tools to expand on it. But in this presentation, what I'm going to do is talk about like what we have seen kind of recurring themes as we're working with people with automation. We're looking at different stuff. It's more of an experience-based presentation. It's things we experienced over the years, and we're going to start with them. So the very first thing is you have to change your design process. So that's the very first kind of assumptions that people see. I think this mostly comes from the history of how people attempted to do automation in the past. So in the past, people attempted to do, they probably have a configured to order product. And what they did is they attempted to kind of monolithically look at an automation as a monolithic big bunch of if and if code with a lot of relations, with a lot of parameters that are playing off each other, in order to create an assembly that can be flexible enough to give them all the output they can possibly get, like program, right? So anybody who's done some program in the past, they will understand what this one means. And in a way, they are changing the way they think about their product by looking at it as a top-down, and I don't mean it top-down as far as the design process top-down, not like skeleton and so, but more of a thinking of the way they build a product is they overload everything. And that's the way for us to automate our to-order product. So that's kind of the very first thing. And now they start thinking that, well, not everything we do and a bunch of other stuff can't be thought out that way. So the reality is that, for us is to kind of change their mind from actually thinking about stuff, this top-down overloaded kind of a model, to a flexible, follow the build process that you do without automation. So the idea is that automation will be a mimic of what you do manually, but with the more defined rules and more regimented rules, in a way, more defined and followed rules without changing the way a product is designed or built. So that's the very first thing that we encounter all the time. And now the second one is going to sound kind of a very similar, and it is very similar because it's all or nothing process. So again, this is also coming from the same idea that people would have like a program assembly. So in program assembly, you're thinking about, I need to build everything. It's an all or nothing approach. Why? Because in program, let's suppose that you build only the 80% or the 90%, because those are easy enough, small enough that you can build them. But as you think about the 10% old options that people are going to order after, that might be 90% of the effort to actually get you there. So then 80, 20, 90, 10. So people would start thinking about that kind of monolithic animation, saying, I need to build everything in there. And all of a sudden, this thing, the scope start becoming massively, which is perfectly fine, but the ROI becomes so late into coming. It takes, the longer it takes to automate, the longer it takes for an ROI to happen, and the bigger the investment and justification is going to be for a product, for an automation like that. So classic problem. And why is that kind of, why they're thinking about having the all or nothing? Because as you know, with a program kind of an automation type, when you wrap all the rules inside the Creo assembly, let's say you can hit 95% of whatever product is that going to happen, and now you're going to tweak the other 5% to address some special or some low frequency options. Once you start tweaking that assembly, everything starts falling apart. That's classic. And even if things don't fall apart, the assembly don't start, failing, because it just happened that you tiptoed around the logic. You are not sure. It's very easy to, without noticing, when you regenerate next thing, it brings it back to where it was before, even though we're trying to get something a little bit different. So that's the all or nothing process. The reality, so for us, the very first thing is that to say, you know what, 80-20 rules. You do the 80% to 20 rules. 80% of what you do, or 90% what you do, takes 10 to 20% of the overall process. And if that can give us the ROI, because it's valuable as is, the rest of them is still usable. Even when you come up with the extra 5-10% that you haven't addressed in the automation, you can easily tweak it in the automation, and the Creo assembly, the Creo parts don't fall apart. The regeneration is not going to affect them. You just added extra logic yourself that are beyond the automation That is perfectly fine, and that is perfectly working. So this is kind of like a process automation, interactive automation that can be layered on top of it, and it can handle those things without any. And the idea is that to get this quick ROI, so it's justifiable. Anything you spend on automation becomes justifiable. Number three is they're gonna go fast going forward. So our products are one-off or ETO, and that is another classic one that happened. So the idea that if our product are two one-offs, or they're very difficult to automate. So product, and there's variation of that. My product is too custom, or my rules are too complex. I don't want to lose customization or flexibility. They're all kind of the same, right? It's like my product is too one-off. And that also comes from thinking about automation of that monolithic kind of a view. While, and frankly, the classic response I always say that is that if your products are, they're always the same, you're generating, there's very little value in automation. The biggest value in automation when you have products that are one-off, so you have a lot of engineering on a per deliverable that has to happen, and you have a lot of complexity, so the potential of errors and inconsistency becomes higher. So automation is, on the contrary, is the biggest value of automation is for one-off and ETO, because that gives you the biggest ROI, because that's reducing the most engineering effort into a deliverable, but also it's reducing most of the inconsistencies and errors that happen because of the rules complexity and the amount of them that's going to happen. So another kind of thought that classically always happen discussing automation with people who are new into automation. So not realizing downstream benefit. And what I mean by that is when usually, at least from our end, and actually from almost everyone, automation is going to start where the process start in design. And the design department, and mostly for to-order products, is they are looking at their consideration of what they need to do. And it's a lost opportunity, but doesn't mean that it's not a valid way of working, as long as you think about what is happening downstream and think about, basically, downstream has a lot of benefit, because manufacturing, for example, is extremely rules-based, which means you can gain a lot of ROI out of considering this output and how to also link up to the manufacturing requirement when you're doing automation. So it doesn't have to happen at the same time, but it's a huge consideration as far as developing a return on investment for the value of what you're trying to do. And it could be a two-phase thing or multi-phase thing, that's fine, but consider downstream as the same time, at least, as a potential benefit for you to continue through. So to us is that we're always thinking about, we're standardizing the design through manufacturing process, and not just the design process, because that's only one of the deliverables, right? People are going to use that data for other stuff. Okay, it's too expensive or time consuming, and that usually comes from people experiencing like ERP implementation, some of these system-wide integration, some of these monolithic automation, also like the program type automation, which is very, very time consuming. I get that. You can get stuff very fast, very little very fast, but then as you scale them, it exponentially gets harder. And for us, what we want to do, again, so how we get around that is that we want to reduce the ROI to weeks, months, not year, obviously. We want to do that by not getting bogged down into those edge conditions. So deal with the 80-20 rules or 90-10 rules, whatever makes sense for a certain thing. The rest of them, they either justify themselves or not, right? Either you make enough of them that are justifiable or not. We do that with proper project scoping. That means understand very well what you're trying to cover, what is an edge condition, and what is a core condition that has to happen, that happens every time. Things that happen every time, obviously they must be part of the scope. Doesn't matter how complex it is or how simple it is. Things that you do that comes up once in a blue moon, you can bypass, knowing that manually you can address them. It's not like you are not going to deal with this product. You can address them as long as the automation does not trip you. And that's a big as long as. So, but there's a big caveat, is that as long as the automation, the 80-20 rules automation, does not trip you when you are manually addressing these edge conditions, then it's perfectly fine, because you're going to be gaining so much in there. These edge conditions, they either will justify themselves or not, or you can do them manually and you're not going to be tripped over the automation. So that's the very next thing. The idea is you remove the bulk of that work, so you can have enough bandwidth with the same headcount to handle all of these edge conditions, even if you want to handle them manually. So that's kind of an approach we think about. So the sixth one is the order of automation. And that is something that I kind of like fell in early on at SIGMAXIM, about 22 years ago, or one of my early projects, right, for a company in the semiconductor business. So we were automating, so their products, you know, looking at this product in the semiconductor business, one of those steps in the in semiconductor tooling is extremely automatable bunch of product line. Maybe there's 20, 30 product line that they would sell, and each one of them is basically customized to the order that is, you know, what the order necessitates them to do with it. So most people, and I'm not going to say most people, a lot of people would look at the problem like that and say, okay, you know what, I want to get into it. I have 30 products I want to automate. Let me start. I'm convinced that in our business, we can gain a lot of benefit by automating the deliverable of our to-order product. And therefore, I'm going to pick one, but in my mind, I'm going to pick one that's easy, so we get easy going into the project, and now then we can go into the next ones. So here's that company, and maybe 20 years ago or more, we automated that product. Very proud of the result. The stuff works like a charm, automatically doing all kind of deliverable, NC deliverable, bunch of documentation, the whole thing, the 3D generation of the whole assembly, everything is working great. So we deliver software working great, everything. They're ecstatic, they're very happy. And so we wait about 2-3 months, and we're looking about, okay, did you finally derive some ROI, and you know, what's going on in there? And I kind of realized that, so the guy tells me, you know what, this thing is working great. The problem is I still don't have good numbers, because this is a seldom ordered product. It's a simple product, but you know, we kind of got onto it, but seldom ordered. And we really will need a long time to kind of get an ROI out, because they're not being ordered that much. So it's basically, I didn't even consider that. So product selection. So when you're talking about a business trying to improve, what product you start with automating should be the most frequently used, not the easiest to automate. The difference between easiest and more complicated is a certain small percentage, let's say 20%. 30%, not even that. So I'm being too generous, because especially first project. First project has to absorb initial setup cost. It has to absorb bunch of things that you do always the same way. The way your drawings look are always the same way. The process, the way you gather your sales order information, your custom order information, it's coming probably from an ERP system. You gather it all the same way, whether it's a simple product or old product. So there is a massive amount of initial cost to automation that happens one time. And now you're absorbing all of that in an ROI for a product that is very seldom going to be used to give you that ROI back. So it becomes very difficult for their business to operate. It becomes very difficult to justify to their upper management that this is really something that we need to continue with. So I get a message that my internet is unstable, or the message is unstable. I'm going to assume it's all working until somebody call me and tell me it isn't. So, okay, so.
It's just fine. You're okay.
All right, perfect. So, okay, so in order for the automation to become a way of the company, the way the company do business, that first project must give a fast ROI, must be, in order to get that justification to continue doing stuff like the rest of the company to absorb it. So look at the most value and at the least effort. The effort itself isn't going to be that big a difference between one versus another. Okay, so the other stuff is companies start looking at how we would justify looking at it like, oh, automation can help us a lot. They're only thinking about time, because that's the obvious thing. Anybody looking at automated and at an automated process, the obvious thing they see is that click, 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 and now those are disappearing. So it's very easy for anybody to look at it and says, wait, this thing is going to get me so much time. And time is obviously things that automation will give us, right? However, the most important benefit isn't the time, is the consistency. The difference is that humans, for something that is regimented, that you already define rules on it, and you want it to always happen a certain way, because why? A certain way means that your downstream process is tying to those consistent results in order to deliver no errors anyway. So while the efficiency is, the time efficiencies are great and it's very easy to see, the biggest result is really in the quality of what you get down. The consistency of the result ensures that your downstream manufacturing and every downstream process is error-free, because you already proved that output. And if there is anything that software is pretty good at, is repeating things. So the software isn't too smart, but it's very regimented. It kind of follows every time, whatever. So it's not simply, you're getting the time to market not from the amount of clicks that you're reducing while you're in Creo clicking on the button, but from everything else that's going to remove for you the downstream error that going to show up, any ECOs that are going to show up later on. Those are how it disappeared, and that's kind of how the biggest efficiency. And I have an example. So Festo, Andreas is from Festo, is a company that basically is a global company. It's a headquartered in Europe, Germany, and they do basically control systems. So his quote, we got it, the time saving, while impressive, obviously it's automation, were surpassed by the quality consistency of the results. So that's kind of his quote, and they kind of realize it on their own, is that, wait a minute, we came onto this project in order to get our deliverable out faster, the drawing deliverables and manufacturing deliverables. But really, where we gained the most is that when we started measuring the quality, the amount of ECOs coming back, those disappeared. Anything that's going to the automation system is not going to have any of that stuff. So that's another point in there. So 8, it will call, and that's a little bit touchy. So this one is yeah, it's a bit touchy, and you know what? It's probably right in certain company. We always hoping that that's not going to be the way, because you, I mean, frankly, engineering job, it's pretty much in any country. I mean, we operate in multiple countries as a company, SIGMAXIM. It's not easy to find qualified engineers to work anyway. So it's not like these engineers, everybody's trying to get rid of them. It's kind of hard to maintain. This issue kind of, it's always, behind, under the surface is that people, oh, there's a risk to job safety. And they start thinking that executing the task, the basic clicking in Creo, is the sole reason becomes for that job. And I mean, if that is the case, that's unfortunate. But the reality is, and if you look at it here from the United States perspective, right? In order to safeguard your job, the only way to do it is if the business is competitive. If the company business is not competitive because they haven't modernized, and automation is one of them, and there's a bunch of other, I mean, it's not like the only thing that you would do, but modernizing how things happen and making more efficient use of talent, and making efficient use of time and of resources, right? If that is not being improved, that company sooner or later will be out of business, or they have to be divested, they have to change. It just happens. If you don't do it, if you don't improve, your competitor will improve. And automation is a weapon. It's a well-known weapon. It's not a secret. So what company basically then have to do is start focusing on strategic initiative, and the engineer's job becomes a valuable asset that is, his job is making easier, but more to do more with less time. Like everything we're doing in life, all the tools that we keep acquiring is to make things more efficient and faster. And automation is nothing other than a tool that's going to allow us to do stuff like that. I basically had to put this one as one of those under the surface. I really don't want to get into automation because there's a risk to my job in there. In reality, we don't see it. The companies aren't so looking to, they basically have time staffing engineering jobs. So it's not like we need to actually find them. So we want to eliminate the boring manual task, make the job of the engineer is actually how to actually help the business become more competitive, and we'll do it. And that's another quote from Hitachi Energy. So they do everything. It's a company that does everything from power transmission to generation to everything, dealing with, power, basically. So that comes from the global engineering manager said, well, our engineers show great interest in automation because they see it as an opportunity to invest their energy in a more value-added activity. They want to be able to provide more benefit to their company. Frankly, companies that have people like that, they only have a way to go up, because you have a lot of people actually now thinking about how we want to improve as a company to become more competitive and more productive, and therefore how else we can help it. So number 9, going on to the next point, is that might think that it won't integrate with business system. And why would they think something like that? Well, it seems that lots of companies, the word integration is in a lot of ways, it's a bucket that in a lot of projects, I just mentioned ERP projects and whatever, they kind of throw it as the integration as a big bucket where we throw everything. It's just like a mysterious buzzword. We have to do integration, and therefore there's a lot of big bucks that are going to thrown in there, and a lot of mystery around how we're going to do integration. So it makes a lot of system kind of how they're going to talk to each other. Now, I don't subscribe to this process. So the reality is that all these systems, they are part of a process, and and each one of them has certain steps in that process. And each one of these steps is bookended. It's bookended by input and output. So any of these systems, when you start thinking about integration with a big buzzword with a quote on it, start thinking about them as being now the process steps move from here to this system. So it moves maybe from CAD to ERP. What information has to go from CAD? That's the output of CAD. What information has to go to the ERP? That's the input to the ERP. And every one of those systems that you work with every day have a mean of taking data and giving data back. Every one of them. So the integration becomes nothing other than what are the steps in my process? What is the input between them? What's the input? What is the transfer of this information between them? So therefore, I need an output from the end of that step, an input for the start of that step. And once we start thinking about stuff in terms of a process with steps, with input and output, then integration is no longer that mysterious, scary buzzword that's going to be throwing, hundreds of thousands of dollars at it just because it is that mysterious buzzword. It's just a simple, now it's very hard to justify these hundreds of thousands of dollars when you start talking about how much is it going to cost to export something and then to import it from the other end. It's a pretty simple then task it becomes. So number 10 is too difficult to maintain, and I kind of agree that this is kind of a SIGMAXIM. Obviously, this is a SIGMAXIM selling point, so it's a plug. It's our sales plug, but obviously it's something that I absolutely believe in, because if I didn't, it's basically my business to define what is important to SIGMAXIM in order to sustain our business. And if I didn't believe that this is a core important point, I wouldn't, we wouldn't spend so much effort into doing it. This is probably our biggest effort as a company, is how to maintain the history of when people make an automation, that makes sure it works in every release of Creo. So, and there is really two angles to this. So the very first angle is what everybody kind of experienced when they do automation in the past, and their automation, they might subcontract somebody, they do automation in release, I don't know, Pro Engineer 2001, and by the time you get to Wildfire 5, it doesn't work anymore, and then the automation dies and nobody uses it and it's gone. So that's an experience that many companies had in the past. Why? Because really advanced automation work with API, direct API to Creo and 𝗔𝗯ance. And direct API lives in a one release of Creo. So next release of Creo, that direct API is a different version. That means you have to redo it. So as Creo start going every year, new version, sooner or later that automation dies. So our claim to fame that I showed in my first or second slide is over 1 million applications running. So for us, that's not an option, because there's no way that we can maintain over 1 million automation. The only way for us to maintain them is to have a systematic way of maintaining them. And so that's a very first concern that has to come up. The second concern is that their product. So you want to automate a certain product, that product keep changing. Because you're improving it. You make a truck, you're trying to make new versions and options and whatever to them. You make a compressor, the same story. Whatever you make, the product is not static because you keep improving it. So how can we automate a configure to order or an engineer to order kind of a product if the product itself, the baseline of that product, is continually changing? So that's kind of the other type of difficult to maintain angle. So the very first one, I think I hinted on it, is that systematically for us, our claim to fame is being able to have all these applications, 1 million plus applications, always up to date to the latest version of Creo. So that is worry-free. It happens. It's actually a huge effort that we put in there into ensuring the system keep working with every release, and even mid-releases. You know, PTC can fix a bug, and that bug is expressed into the way certain things are behaving. So that's not an option for us. We have to ensure once the automation work in a certain way, once a feature works in a certain way, it always works the same way. Now, the second part is a little bit more nuanced, is that my product keeps changing, and therefore I can't anymore look at the logic and build it inside this this like overloaded assembly, like program. So we have to look at it in terms of externalization, in terms of what we call virtual master model. And that means we separate the logic of how the rules work from the data that is changing, your part that are maybe coming from suppliers and stuff like that, where you can very easily swap new one in and there, add new ones, remove something that is now no longer orderable, etc. So that's kind of the other approach that many people think about, and if they don't think about, they have to think about, but we think about pretty much every day. And I have a bonus. This is one bonus, so it won't take too long, is our data is not consistent enough in order to automate. Of course, that's what everybody is, because people spend 30 years building data. Obviously, that data is not going to be consistent. It's not going to have, you know, naming. It's going to have proper parameters. It's not going to have, you know, proper views. They're going to have, there's nothing's going to be consistent. No matter, even if you have rules, you might have put the rules later on in the process, but you still have tons of parts that are old. Disparate data sources, they might be coming from different CAD systems, and they might be, or suppliers, right? So you might have stuff from, they're not all Creo. You started with some other system, you move into Creo, now half your data is imported from, you know, different systems. So, and manually clean it up is very expensive. You're not going back to 30-year history in order to automate your product. Go to 30-year history to start tweaking product that were already released, and we're not going to touch them, or parts that were already released, we're not going to touch them. So, and even if you want to do that, the more people you throw at cleaning up the problem, the more inconsistent you're going to get that data. It's just humans aren't really made to do consistency. So, and that's kind of a bit novel for us. So what we do, as a matter of fact, about like maybe 10 years ago, we had, we presented at PTC User, in the global PTC User, something called Automate Your Way to Automation, which is kind of an idea that we do, and now we use it all the time, is to take, you know, make a core automation that's going to sit there and sift through your hundreds of thousands of parts and assemblies and find what's inconsistent with them. And it can fix certain things, but anything that can be fixed, at least now you have a list of what is the punch list that you have to do with the few things that are really needed to be fixed. And as an advantage, then this sifter then becomes your gate in order to new parts that you're still adding to that system. It becomes that they will not go into the automation unless they pass that logic gateway, that sifter that is looking at the inconsistency. So that's one way for us where we use the automation in order to enable automation. And because obviously we're a bit, because we've worked now for so many years in automation, we're a little bit allergic to manually going and clicking on data. So that's how it is. So here's an example, is a company bought Longyear. Their legacy needs, so they wanted to automate some of their products, and their data basically comes from 80,000. In order to build the product, they have legacy CAD drawings and parts and etc. From 80,000, there's 80,000 of them basically. And what we needed to do is extract parameter, vault into Windchill, clean up a bunch of stuff. And that's kind of one example where they talk about it. So we have tons of them, but obviously we can't talk about project we do for customers unless they talk about it in some publication. And here you go. So in this case, we've used an automation in order to sift through all their history. And once we sift into through all their history, we extracting the parameters, vault them, do anything we want to do with it. And then this becomes available for the automation going forward. So the idea is using automation for these things. In summary, so automation provides greater control and consistency. It enforces standard procedure, and you start thinking about automation as a platform for continuous improvement by designing consistency. So consistency is not kind of a hopeful byproduct, is really part of what you're designing in there. Now, here is something you see. The slide now has a different color because I basically stole it from Randy Calland from Xylem. So he presented at Harley-Davidson a couple of months ago, and I was there. So he was presenting their automation, and that's very specific. So it's a totally different presentation that I'm doing. He's talking about them as a company, what they've seen after they've taken a bunch of their products and automate them. And that's coming from him. Basically, any company can benefit. Easy to write your own application, obviously. So he's giving us a plug here. That's fine. Get more from Creo investment. That's what they're seeing. By automating Creo, you get more from your investment in Creo. And you start focusing on other process area that you can improve. That maybe you won't even automate, but then you'll have the time now to start. By taking all of those efforts and automate them, you're not putting any more effort into the day-to-day for these apps that you automated. Fewer manufacturing errors. I think I hinted on that by saying that downstream, basically, you're not seeing errors. And the benefit is not just the time, but rather the error and the consistency. Save time, he said it, and better customer communication because it's consistent. So the consistency gives that. My last slide is that how we do it, what we look at. So for us, the advantage is, so I'm going back to the plug in the first thing of what we do as a company. Basically, we view ourselves as automation expert. Everybody, that's what we do every day. So we kind of like it. So what we want to do, what we value doing is that any project we get on, and anything we advise on for people to make their own automation as well, is that to try to get immediate ROI, very, very fast ROI, because that's what justifies putting more effort into other stuff, other things to automate. We approach automation as a building block. Building block, that means the logic and how it works is standalone, it's smart, it knows how to do it. And that's the only way to scale. Scaling product and scaling complexity is by looking at these building blocks. And that we like to say it's infinite scalability because it does not matter, because it's basically more blocks that, and you can keep adding as many as you want to. So the automation itself has elements, and these elements are block. We build them by adding blocks. And the last leg of our five-legged benefit advantage is the worry-free maintenance, because if we have to worry about everything we automate now is going to continue working in next releases, we build 3 things, and from here on, or 5 things, or 6 things, or depends how much time we put in it, and from here on, all we're doing is maintaining our product to make sure it works in the next release of Creo. That's a major thing that if that doesn't happen, none of the other stuff have any value. Excellent.
Do you have any examples?
Yes, tons. So examples of what automation might look like. Yes. So let me, well, yeah, I have tons actually, but let's start with maybe something like that.
If you have any off-the-shelf automations that are popular, you could show those.
Well, off the shelf, so off the shelf, yeah, we do have few things. So for example, MBD, we have some MBD tools for automations that on themselves, they're kind of like, everybody can use them, like validating MBD output or whatever. But by its own nature, automation is the automation of your own process yourself. So hard to say that. So it's not something that you take, you install and you run it in your company. It's something that you take, you install, and now you look at your own process and you map it into the software to do what you want to do. So so I think it's a good question that you ask me for. Do you have an example? Let me give you an example. So let's look at something like that. So what this is a, I mean, I show it a lot because I like it because it's graphical and people see what's happening. So in this case, these people do fire suppression room in, you know, these high rises and factories and whatever. So commercial building. So a fire suppression room is a ETO, is a two-order product because you're trying to fit it into a certain environment, and they kind of have to fit that environment. So you're going to think that what you saw in the beginning is that there are a bunch of input. I want to stop it a little bit. There's a bunch of input that is telling us what people want, what people are ordering, what they want. And out of those efforts is basically what we're going to do is by rules, we're going to select a certain pump, a certain engine based on torque. We're going to figure out, the system automatically is going to figure out, okay, this is the coupling that has to happen in there. And now we're going to start building in Creo some of, you know, the inlet, the outlet, etc., of the flow. Depends on how much flow we're trying to kind of push through, how much pressure we want, etc. And then we're doing some validation, and you're looking here that, listen, that does not fit in there. So by rule, I have to start a new branch, and I'm gonna have to build out that blue branch based on what we are trying to fit in there. I have to put some valves in there, and that's gonna need then for me to adjust these, to adjust basically the piping in order for me to fit all of that stuff in. So again, you know, it's automation. So where you're making some decisions in order to address input. So basically some controls based on the jurisdiction you're in. This control has to be certain distance. The oil tank has to be certain distance. We move it. Now the door does not fit, so we're gonna move it in there. And now that we have all the heavy stuff where it's supposed to be, now we can figure out where the structure has to be. So then the structure has now to be, can be designed based on all that input that we can measure. And out of that, once we build the 3D assembly like Creo, then you have your drawing. Your drawing can be built the same way you will build the drawing normally, some delivery package that you have to come out with, and any other deliverable that makes sense in that case. I mean, some of those deliverable can be that now that we have built this assembly, we can go and submit a BOM to your ERP system in order to get the stuff in there. By the way, this is actually a good example even of what I talked about as far as the data isn't consistent. Most of that data comes from imported from other systems. From most of that data that you see here, those parts, you know, come from, I think, Solid Edge or something like that. And that means we had to make sure stuff are consistent as we are importing stuff. It's all part of this whole same project in a way. So that's an example of a CTO, ETO type product. So configure to order, engineer to order. This is an engineer to order kind of a product. So that's kind of how both CTO and ETO type automation work. But as you've seen in my first one, there's a lot of practices for automation that don't even involve this automatic build of product. It's kind of interactive usage of Creo and how we can streamline that usage. So there's many, many practices for automation. Hopefully this gives you a flavor.
Thank you.
But we're happy to, you know, like one-on-one, we can show a lot of different things. So we can get into a lot of stuff. So it's great if you're interested.
Okay, real good. Thanks so much, Charles, and appreciate your time. And
thank you for organizing, Deborah.
Contact SIGMAXIM at info@sigmaxim.com for more information on our groundbreaking Creo automation solutions.